Welcome to Orbit Observer. Settle in for a moment. Let your shoulders come down from wherever they've been sitting all day, up somewhere near your ears, and let them drop. There is nothing left for you to do tonight. Nothing that can't wait until the light comes back. So let me tell you about something very small and very far away. Something almost no one thinks about. A thing barely 1/2 kilometer wide, drifting in the dark at the far edge of a giant planet, quietly coming apart into a ribbon of light. 1/2 kilometer. That's it. That's the whole of it. About the length of a large sports stadium or a single city block in a sleeping town. You could, in principle, walk the entire way around it in an afternoon, taking your time, stopping to rest. It is the smallest named moon of Saturn, the smallest of that whole enormous family of moons circling the ringed planet, and its name is Aegaeon. And the strange, soft, almost tender thing about it, the thing I want to walk you slowly into tonight, is that Aegaeon is turning into a ring, not being smashed, not exploding. Just gently, grain by grain, surrendering itself into a faint arc of light that it happens to float inside of. A moon becoming a ring, a single body existing in two states at once, one solid and one scattered, the solid one slowly feeding the scattered one, night after night, century after century, in perfect silence. Hold that image for a moment. A tiny world, out there in the cold, so small it hardly counts as a world at all, letting go of itself so slowly that no single moment of the loss can ever be seen. That's where we're going tonight. And there is no hurry to get there. There is no hurry anywhere in this story. Let me give you the first strange fact, the one that unlocks everything else, and I'll give it to you gently. On Aegaeon, you could not walk. Not really. Not the way you walk across a room. Because Aegaeon is so small, and its gravity so faint, so nearly nothing at all, that the tiniest push against its surface would send you drifting up and away from it, off into the dark, and you would not come back down. Its escape velocity, the speed you'd need to leave it behind forever, is measured not in the miles per hour of a rocket, but in centimeters per second. A gentle push, a slow exhale of movement. On this moon, a single soft jump, the kind of jump you barely think about, the kind a child makes stepping off a low curb, would be enough to leave it behind for good. You would rise and simply never return, and Aegaeon would grow smaller and smaller beneath your feet until it was just another point of light in the arc it belongs to. Sit with how quiet that is. A place so gentle, so nearly weightless, that leaving it takes no violence at all. You do not have to fight to escape Aegaeon. You only have to let go, just a little, and the letting go does the rest. Keep that feeling nearby. We're going to come back to it, because it's the whole reason this moon is dissolving, and it's the whole reason this story ends up feeling less like a loss and more like a kind of release. Before we go deeper, I'd love to know where in the world you're listening from tonight. Whatever quiet corner of the planet you've folded yourself into. Wherever your window is, and whatever dark lies outside it, tell me in the comments when you wake, if you feel like it. It's a small thing, but I like knowing there are people out there in the dark with me. All of us turned toward the same far-off little moon. And if you're new here, if you've only just found this quiet place, you're welcome to stay. Subscribe if you'd like more slow journeys like this one, and then let it go. You don't need to do anything else, just let the words carry you. So Aegaeon, let me tell you how we came to know it was there at all, because that too is a slow and patient story, the kind that unfolds over decades and asks nobody to hurry. For most of human history, no one had any idea this moon existed. How could they? It's 0.5 kilometer across, hidden in a faint and dusty ring, more than 1 billion kilometers from Earth. It is, by every measure, one of the smallest, dimmest, most easily overlooked things in the entire solar system. It kept itself hidden not through any trick or intention, but simply by being so small that the light it reflected was almost nothing. A whisper of brightness inside a whisper of a ring. To find it, you would have to already be there, out at Saturn, drifting close, spending years in the neighborhood, looking not for a moon at all, but at the faint band of dust that turned out to contain it. And that is exactly what happened. There was a spacecraft called Cassini. We'll spend time with Cassini tonight, because in a strange way its story rhymes with Aegaeon's. But for now, just know that Cassini was a robotic explorer about the size of a school bus, sent out from Earth to live at Saturn, to orbit the great ringed planet again and again, year after year, and to look closely at everything there was to see. And on the 15th of August, in the year 2008, the imaging team working with Cassini, the people whose whole job was to study the pictures the spacecraft sent home, were looking carefully at one of Saturn's fainter, dustier rings, a ring called the G ring, and inside a bright, curved smudge of material along its edge, they noticed something. A point, a single small bright point that hadn't been catalogued, hadn't been named, hadn't ever been seen by human eyes before. Not a discovery announced with trumpets, not a moon they went hunting for. Just a bright dot, noticed by patient people studying a faint arc of dust closely enough and long enough to see the thing hiding inside it. They gave it a plain and careful name at first, the kind of name astronomers give a new thing before they're sure what it is. They called it S2008 S1. Which is just a code, really, a small bureaucratic label. The S2008 tells you it was a satellite first seen in 2008. The S tells you it belongs to Saturn. The 1 tells you it was the first of that year. A placeholder. A name that says, in effect, we've found something here, and we'll give it a proper name once we understand it better. And they did. In time, this small world was given its formal place in the roll of Saturn's moons. It became Saturn LIII, Saturn 53. The 53rd of Saturn's moons to be numbered and confirmed, which tells you, all on its own, how crowded and how strange the neighborhood around that planet really is. And then, in 2009, the International Astronomical Union, the body of scientists who hold the quiet responsibility of naming the things we find in the sky, gave it its true name, Aegaeon. Now that name is worth lingering on, because it carries a small and beautiful irony that fits this moon perfectly. Aegaeon is a figure out of Greek mythology. In the old stories he is also called Briareus, and he was one of the hecatonkers, which is a wonderful, tongue-tangling old word meaning the 100-handed ones. The hecatonkers were giants, enormous primordial beings, children of Uranus and Gaia, of sky and earth, and they were monstrous in scale. Each one said to have 100 hands and 50 heads. Vast, powerful, ancient, the kind of being the earliest myths reached for when they wanted to describe something too large for the mind to hold. And that titanic, 100-handed, 50-headed giant is the name we hung on a 0.5-kilometer speck of ice, a moon so small a gentle jump would leave it forever. There's a gentleness in that irony, isn't there? The tiniest named moon of Saturn, wearing the name of one of the largest beings the old world could imagine. As if to say, size is not the only measure of a thing. As if this small, quiet moon, in its slow surrender, is doing something as grand in its own way as anything a giant could do. And Aegaeon is not alone in carrying such a name. There are other tiny moons out there in the same part of Saturn's system, other little ark-dwelling worlds, and they too were given names from that same corner of myth. There is Methone and Anthe and Pallene, small siblings all, named for the Alkyonides and figures related to them, so that the naming itself gathers these little bodies together, like children of one family given names from one story. We'll meet those siblings later, further along in the night, because they turn out to be doing the very same thing Aegaeon is doing, each in its own quiet way. For now, just hold the name. Aegaeon, the 100-handed giant, shrunk to a stadium of ice, drifting in the dark. Now let me show you where it lives, because the address matters. It matters a great deal, actually, to the whole mystery of how this moon is becoming a ring. Saturn, as you may already picture it, is the planet with the rings, the great, bright, sweeping rings, the ones that make it the most beautiful thing in the solar system to look at through even a small telescope, that flat, shining disk tilted around the planet's waist. But those bright, famous rings are not the whole story. Saturn is wrapped in many rings, and some of them are not bright at all. Some are faint and dusty and thin, more like a haze or a breath of scattered material than a solid band, and it's in one of these faint outer rings that Aegaeon makes its home. The ring Aegaeon lives in is called the G-ring. It sits out past the bright main rings, past the narrow twisted ring called the F-ring, and it sits inside the vast, enormous, diffuse ring called the E-ring, which is so wide and so soft it's more of a cloud than a ring at all. So picture the G-ring nestled between those two. Fainter than the F-ring that lies inside it, far more compact than the great pale E-ring that lies outside it. A quiet, dusty, in-between place. The G-ring drifts at a distance of roughly 166,000 to 175,000 kilometers out from the center of Saturn, a thin haze of fine material circling the planet in the cold and the dark. And along the inner edge of that faint G-ring, there is something special. There is a brighter place, not a full, complete, unbroken ring, but a partial one. An arc, a curved concentration of material that stretches around only a portion of the whole circle, not the whole way around, but only about 1/6 of the way, spanning something like 60 degrees of the great loop around Saturn. Imagine a clock face, and instead of a full circle of numbers, imagine just a bright, glowing smudge stretching from, say, the 12 to the 2. That curved, glowing, partial band is the G-ring arc, a ring that is only part of a ring, a brightness that gathers in one region and thins away everywhere else. And Aegaeon lives inside that arc. It is embedded within it, a small solid point buried in the brightest concentration of the faint G-ring, orbiting Saturn at a distance of about 167,500 kilometers, going around and around the great planet once every 19 hours or so, once every 4/5 of an Earth day. Around and around and around, through the cold, never resting, never stopping, carrying its little brightness with it, or being carried by it. We'll get to which of those it is, because that turns out to be one of the loveliest open questions in this whole story. But do you feel the shape of the mystery forming now? Here is a moon, the smallest named moon of a giant planet, tucked inside a bright curved arc of dust, an arc that goes only part of the way around. And the claim, the strange soft claim at the heart of tonight, is that the moon and the arc are, in some deep way, the same thing. That the bright arc of light Aegaeon floats inside is made, in significant part, of Aegaeon itself. That every faint grain of that glow is, or once was, a piece of the moon. How can that be? How does a moon become a ring? How does something solid, something with a name and an orbit and a place in the roll of Saturn's satellites, become a diffuse band of scattered light and keep on being a moon the whole time it's doing it? That's the question. That's the master mystery I want us to hold open through the whole of this slow night. Not rush to answer, not solve in a single breath. Just hold, the way you'd hold something small and fragile in a cupped hand, turning it slowly, letting the light fall on it from different angles. Because here is the thing about this question. It does not resolve into something frightening. Sometimes we hear that a thing is being worn away, is dissolving, is disappearing, and something in us tightens. Some old fear about loss and ending and things running down. But Aegaeon is not going to teach us to be afraid tonight. If anything, it's going to teach us the opposite. It's going to show us, very slowly, that to be small and to scatter and to become part of something larger and softer and more diffuse than a single hard point might not be a tragedy at all. It might be a kind of belonging. It might be a kind of rest. So let's begin to draw closer to it. Let's leave the bright famous rings behind, the ones everyone knows, and drift outward, past the F ring, into the faint dusty region where the G ring hangs in the dark, and find the bright arc, and find, inside the arc, the small point of ice that is our moon. You have to understand just how faint all of this is. The G-ring is not a thing you would ever see with your eyes if you were floating there beside it. It is a haze, a suggestion, a thin scattering of fine particles that you would only really notice if the sunlight caught them just so from behind, lighting up the dust the way headlights catch a fine mist on a country road at night, turning the invisible visible for just a moment. The whole ring is dust and small grains spread thin across an enormous volume of space, and the arc, the bright part, is simply where that dust gathers more thickly, where more of it pools together in that one stretch of the orbit, glowing a little brighter than the rest. And it took us a long, long time to know any of this was there. That's the part I find quietly moving. This knowledge did not arrive all at once. It accreted slowly, the way the dust itself gathers, one small addition at a time, over decades, until finally the picture was complete enough to see the moon inside. It began, in a sense, in 1979, with a spacecraft called Pioneer 11. Pioneer 11 was one of the very first machines humanity ever sent out that far, out to Saturn. A small, brave scout crossing distances that are hard even to say aloud. And Pioneer 11 didn't take a beautiful picture of the G-ring. It couldn't. What it did was pass through the region and notice something in its instruments, a faint change, a dip, a ghost of a signal in the charged particles around Saturn, the kind of subtle disturbance that a thin ring of material would make in the space around it. Not a photograph, not a clear image, just a hint, a whisper. Something is here, something faint is out here, absorbing these particles, leaving its faint fingerprint on the space around Saturn. The first ghost of the G-ring, felt rather than seen. Then came the Voyagers in 1980 and 1981. The Voyager spacecraft, those famous travelers, swept past Saturn and turned their cameras on the rings, and this time there was an image. Faint, dim, but real. The G-ring appeared at last as an actual band of material, no longer just a ghost in the particle data, but a visible, if barely visible, ring of dust. And still, at that resolution, from those fast flybys, no one could see the detail. No one could resolve the bright arc within it. No one could possibly have seen a half-kilometer moon buried inside. The G-ring was known now to exist, but its structure, its secret, its small solid heart, remained hidden. And then, decades later, Cassini arrived to stay, not to fly past, but to move in, to orbit Saturn year after year, to circle it again and again, patient, unhurried, watching the same faint ring not for minutes but for years, building up image after image, until at last the fine structure resolved, until the bright arc separated out from the fainter ring around it. Until, in those images from August of 2008, that single small bright point revealed itself, sitting inside the arc, and someone realized they were looking at a moon. Do you see the shape of that? The knowledge itself gathered the way the ring gathers, first a ghost, a faint signal in 1979, then a dim image in 1980 and 1981, then, decades on, the patient resolving of the detail, the moon appearing at last out of the haze in 2008. Grain by grain, our understanding accreted, until the small, solid truth of Aegaeon condensed out of the faintness. It's a slow way to learn a thing. But it's the only way we could ever have learnt this one. You cannot rush your way to a half-kilometer moon in a dusty ring 1 billion kilometers off. You can only go there and stay and look and wait and let the picture build. There's a comfort in that, I think, for anyone lying awake. So many things can only be known slowly. So many quiet truths only reveal themselves to the patient, to those willing to stay in one place and keep looking long after the fast travellers have swept past and gone. Aegaeon waited billions of years to be seen, hidden in plain faintness, and it was only found because something finally stopped rushing and settled in beside it for a while. And now that we've found it, now that we know it's there, we can begin to ask the real question, the one we're going to spend the rest of this journey with. How is this moon becoming a ring? What is actually happening out there in the dark to turn a solid little world into a band of scattered light? The beginning of the answer, the very first thread of the mechanism, is this. Aegaeon is being touched, constantly, endlessly, by the smallest possible visitors. Space, even the empty seeming space around Saturn, is not truly empty. It is threaded through with tiny grains of interplanetary dust, micrometeoroids, minute high-speed specks of material drifting and racing through the solar system, far too small to see, far too small to do any harm to something large. But they move fast, very fast. And they are always arriving, and Aegaeon, drifting there in the dark, is always in their path. Each one, when it strikes, is almost nothing, a speck hitting a stadium. But each strike knocks a little fine material loose from Aegaeon's surface, a tiny puff of dust chipped free by a tiny impact. And then another. And then another. Not an explosion. Not a catastrophe. Just a steady, gentle, ceaseless sandblasting, so soft on any single occasion that nothing seems to happen at all. A rain of specks, too small to matter, each one loosening a whisper of dust from the surface of the little icy moon. And now, hold that together with the other fact, the one I asked you to keep close from the very beginning. Aegaeon's gravity is almost nothing. Its escape velocity is measured in centimeters per second. A gentle jump would leave it forever. So when those specks of dust are chipped loose from Aegaeon's surface, when that fine material is knocked free by the endless soft bombardment, what happens to it? It doesn't fall back down. It can't. On any ordinary world, on a moon with real gravity, the dust kicked up by an impact would rise and then settle back to the ground, drawn home again by the pull of the world beneath it. But Aegaeon has almost no pull at all. So the dust that's knocked loose simply drifts away. It rises and keeps rising and does not come back. It leaves the moon behind, exactly the way you would leave the moon behind if you gave that gentle jump, drifting up and outward into the space around Aegaeon, into the very arc the moon is orbiting inside. And there it is. That's the first turn of the whole thing, the first glimpse of how a moon becomes a ring. The dust that's chipped from Aegaeon cannot fall back, so it escapes, and it spreads, and it joins the faint bright arc. And the arc, in turn, is fed and brightened by this endless soft shedding of the moon's own body. Grain by grain, Aegaeon gives itself up to the ring. Grain by grain, the ring is built out of the moon. We'll follow that thread much deeper as the night goes on. We'll ask why the escaped dust stays gathered in an arc instead of smearing all the way around Saturn, and the answer to that will bring us to a distant, larger moon reaching across 100,000 kilometers of dark to hold this little one in place. We'll ask which came first, the moon or the arc, a genuine puzzle with no easy answer. We'll meet Aegaeon's small siblings, the other tiny moons doing the very same thing. And we'll sit at the very end with what it might mean for us down here that a small scattered thing at the edge of a giant world is not being destroyed, but is simply, softly, becoming part of something larger and more diffuse, and in its own faint way, more beautiful than a lone rock in the dark. But there's no need to reach for any of that yet. For now, let's just stay here, in the quiet, beside this small moon, and watch it shed its faint dust into the arc, one grain at a time, the way it has for ages beyond counting, the way it will for ages more. There is no rush in it. There is no violence in it. Just the slow, patient, ceaseless letting go of a tiny world so gentle that leaving it takes no effort at all. Let the picture hold in your mind. Saturn, enormous and calm, wrapped in its faint outer rings. The G-ring, a thin haze of dust between the F-ring and the great pale E-ring. The bright arc gathered along the ring's inner edge, glowing softly, spanning only a sixth of the way around. And there, buried in the brightest part of the arc, a half-kilometer point of ice, the smallest named moon of the whole system, Aegaeon, 100-handed giant shrunk to a stadium of frost, turning slowly around the great planet once every 19 hours, quietly, endlessly, giving itself away. And all of it silent, all of it slow. All of it happening, whether anyone watches or not, whether anyone remembers the name or not, out there in the cold and the dark, where the sunlight is thin, and the only motion is the patient drift of dust settling into an arc of light. Breathe with it for a moment. In, slow, out, slower, the moon out there is not holding on to anything. It is simply, gently, letting go, and in the letting go it is becoming something new. There is nothing to fear in that. There is nothing to fix, nothing to solve, nothing that needs you to stay awake and watch over it. It has been doing this for longer than there have been eyes to see, and it will go on doing it long after tonight is forgotten. So let yourself drift a little closer to it as we go. Let the distance between you and that small quiet moon grow thin. We have a long way still to travel through this night, and there is so much more to tell about the invisible tether that holds the arc together, about the faraway moon with the great crater that shepherds this speck from across 100,000 kilometers of nothing, about the whole hidden family of little dissolving worlds tucked into their own faint arcs. And we'll come to all of it, unhurried, in time. For now there is only Aegaeon, 1/2 kilometer of ancient ice, drifting in its arc of light, shedding itself grain by grain into the dark, so gently that no single moment of the change could ever be seen. A moon becoming a ring, a small thing becoming part of something larger, and you, here in the quiet, watching it let go, and beginning, perhaps, to let go a little yourself. To begin to understand what Aegaeon actually is, not just its name, not just the fact of its existence, but the texture of it, the weight and the feel of it, insofar as we can speak of feeling something we have never touched and likely never will. It helps to start with the simplest question: what is it made of? And the honest answer, offered carefully, is that we believe it to be ice. Ancient, dirty ice, the kind that does not sparkle, but absorbs the thin sunlight and gives back very little. Something like a snowball that has been sitting in the dark for 4.5 billion years, gathering the faint grime of deep space, compacting and recompacting over inconceivable stretches of time. Not a solid, dense thing like the rock you might hold in your hand. Scientists believe it is more likely what they call a loose, porous body, something closer in structure to a heap of lightly frozen rubble than to a stone. More gap than matter, more air than ice, the pieces of it held together not by any great internal cohesion, but simply by the most marginal whisper of its own gravity, which is itself almost too small to measure. You could think of it, if you like, as a structure not entirely unlike very old, very packed snow, the kind that has been pressed together slowly over years until it holds its shape, but would still crumble if you pushed your thumb into it. Except that Aegaeon has been doing the equivalent of that slow pressing for a time span that makes human words for duration feel inadequate. This is all, it should be said, our best inference. Because Cassini never flew close enough to Aegaeon to give us a sharp image of its surface, or to measure its gravitational tug with any precision, or to sample its composition directly. What we know about what it is made of we have deduced from brightness, from how much light it reflects, and from what we know about the neighbourhood it inhabits, which is a cold, distant, icy part of the Saturn system where ice is the common currency of small bodies. So when we say it is believed to be icy and porous, we are speaking the language of careful inference. The language science uses when it knows a great deal but has not yet touched the thing itself. That is the honest frame. And it is, in its own way, a beautiful one, because it means that even now, years after Cassini found this moon, Aegaeon still holds some of its mystery close, still refuses to give everything away. About 1/2 kilometer across. That is the figure that appears in the literature, and it carries with it the same gentle qualification, derived from brightness, not from a direct measurement, so there is real uncertainty baked into it. The mean radius is often quoted as somewhere near 3/10 of a kilometre, about 300 metres from its approximate centre to its approximate edge. Give or take the irregularities of a body too small for gravity to have smoothed into a sphere. Call it roughly 500 metres from one side to the other, and understand that this is an estimate. An honest, careful estimate from people who know how to read the language of reflected light, but an estimate nonetheless. 500 meters. Half a kilometer. In the context of Saturn's moons, which include worlds like Titan with its thick nitrogen atmosphere and its lakes of liquid methane, and Dione and Rhea and Tethys, each hundreds of kilometers across, and Mimas at nearly 400 kilometers in diameter, half a kilometer is almost nothing. It is the size of a thought. It is the size of a single city block, roughly, depending on which city and which block you are imagining. Or picture a large sports stadium, not the parking lot, not the surrounding streets, just the stadium itself, the oval of seats and the field inside. That is about the scale of Aegaeon. A world the size of a place where people gather to watch a game. And in the middle of nowhere, orbiting a planet so vast that Earth could fit inside it over 700 times, this little stadium-sized lump of ancient ice floats in its arc of light and goes on quietly existing and shedding and becoming. Its self-gravity, as a consequence of this smallness, is almost negligible. This is not a word used loosely. Gravity depends on mass, and mass scales with volume, and volume scales with the cube of the radius. So when you go from something like Mimas, nearly 400 kilometers across, to something like Aegaeon, at roughly half a kilometer, you are not just making a smaller version of the same thing. You are crossing into a qualitatively different kind of world, a world where the force that holds everything together on Earth and pulls the oceans into tides and keeps the atmosphere from floating away into space has been reduced to something so faint it barely registers. We can estimate the escape velocity of Aegaeon, the speed at which you would need to throw something, or run, or jump, in order to leave it behind and not be pulled back, and the figure comes out to somewhere in the range of centimeters per second. Not meters per second, the way it would be on a larger body. Centimeters per second. The speed at which a slow caterpillar crosses a leaf. The speed at which water oozes from a very gently tipped glass. That is all the speed you would need to leave Aegaeon forever. A walking pace would be too fast. A brisk step would send you sailing off the surface and away, into the ring arc, joining the dust. You would need to move with extraordinary caution to stay on it at all, the kind of caution that amounts to barely moving, to drifting along its surface like a cloud shadow drifts across a hillside, slow and light, and barely there. This is the physical key to everything that follows. This is why the story of Aegaeon is the story it is, rather than some other story. If Aegaeon were bigger, if it had more gravity, if it could hold on to the material that the micrometeorites knock free of its surface, it would be a moon and nothing else, a small, unremarkable body orbiting Saturn, unlikely to have been discovered at all, but certainly not becoming a ring. The nearness to zero of its gravity is the condition that makes the transformation possible. It is the unlocked door through which everything escapes. Now, the place where Aegaeon lives. Because where a thing lives shapes what it is, shapes what becomes of it, and the neighborhood Aegaeon inhabits is specific and strange and worth describing carefully. Saturn has rings. You know this. Everyone knows this. In the way that certain facts about the world become common knowledge so early in life that you cannot remember learning them, cannot remember the moment you first encountered them. Saturn has rings, and Jupiter has a big storm, and the Sun is a star. These things arrive in childhood and stay. But the rings are not one thing, they are many things, a whole system of distinct structures, each with its own character and its own history, and its own population of moons and particles and gaps. and they extend across a span of space that, if you could somehow lift them off Saturn and lay them down on the surface of the Earth, would stretch from one side of the continental United States to somewhere past the other. The rings are vast in a way that is difficult to hold in the mind, and within this vast system, the G-ring is one of the faint ones. Not one of the famous ones, not the bright, wide A and B rings that shine in telescopes from Earth, not the narrow, braided F ring just outside them. The G-ring is faint, dusty, diffuse, a ghost of a ring compared to the brilliant ones closer in. It sits in the outer part of the ring system, beyond the main rings, beyond the F ring, and short of the enormous, diffuse E-ring that Enceladus exhales into being. Its inner edge lies at roughly 166,000 kilometers from Saturn's center, and its outer edge extends to somewhere around 175,000 kilometers. That is a wide band of space, but the G-ring is thin and faint and spreads itself across that band so thinly that for a long time the finer details of its structure were simply invisible to everything humanity had sent up to look. Aegaeon orbits at about 167,500 kilometers from Saturn's center. That places it near the inner edge of the G-ring, drifting through the fainter, thinner dust that extends outward from it, tucked into the most concentrated and interesting part of the ring's structure. Its orbital period, the time it takes to complete one full circuit of Saturn, is roughly 0.81 of an Earth day. Call it about 19.5 hours. Not quite one full rotation of the Earth on its axis. So while you sleep tonight, while the night deepens and the hours pass and the darkness outside your window goes through its slow stages toward the first grey suggestion of dawn, Aegaeon, out there in the cold, will have completed most of one full orbit of an entire planet. A planet so large that every continent on Earth, arranged side by side, would not cover the visible face of it. And Aegaeon goes around it in less than a day. This is worth sitting with for a moment. The smallness and the speed of it. A body the size of a stadium drifting through a ring arc, making its full circuit of a gas giant in the time it takes the Earth to almost complete one rotation. There is something calming in that, if you let yourself feel it rather than calculate it. The quiet constancy of it, the fact that it has been going around and around out there for a time span our language cannot easily hold, unmeasured and unnamed for nearly all of that time, simply orbiting, simply existing, simply shedding a little more of itself into the arc with every pass, and we did not know it was there for a very long time. This is part of the story of Aegaeon, and it is also, in its quiet way, a story about how knowledge accumulates, how understanding accretes, like dust around a resonance point, building slowly until suddenly there is something you can see. The first hint of the G-ring came in 1979. Pioneer 11, a spacecraft that had been traveling since its launch in April 1972. A modest craft by the standards of what would come later, a long, thin antenna with instruments attached, sent outward through the solar system on a trajectory that would take it past Saturn, Pioneer 11 did not photograph the G-ring. Its instruments could not have resolved something so faint. But as it passed through the outer regions of the Saturn system, its charged particle detectors noticed something. A dip. A reduction in the number of energetic particles the instruments were counting in a region of space where there had not been a known structure to cause such a dip. In the same way that you might infer the existence of a physical object in a dark room by noticing that a draught of air which had been reaching you from one direction. is now blocked, so Pioneer 11 inferred the existence of something in the G-ring's location by noticing that the stream of charged particles from space was being absorbed, intercepted, by something diffuse and real. There was something out there, even if the instruments could not see it directly. A ghost of a signal, a shadow cast by something not yet seen. Then, in 1980 and 1981, the Voyager spacecraft, first Voyager 1, then Voyager 2, flew through the Saturn system in succession, their cameras far more capable than Pioneer 11's particle detectors, their passage a true encounter rather than a brief detection. And Voyager confirmed it. The G-ring was there, a faint, narrow smear of reflected light in the images, its position consistent with what the charged particle shadow had suggested a year or two earlier. Voyager could not tell you much about it. It was still too faint, too thinly spread, too far from the spacecraft during its hurried flyby to reveal its finer structure. But it was no longer inferred. It was seen, imaged, real. And there the story of the G-ring's discovery largely rested for more than 2 decades. The ring was known to exist, its approximate location was known. And that was about all. There was something there, a faint, dusty structure in the outer ring system, and it had a name, and people who worked on Saturn's rings knew about it, and that was the extent of it. The detail was there, in the dark, waiting. Just as Aegaeon itself was there, in the dark waiting, neither the arc nor the moonlet hiding inside it was visible from this distance, with these instruments at these brief encounters. They would take more time, they would take a different kind of attention. And that attention arrived on the first day of July 2004, when the Cassini spacecraft, launched in October of 1997, after years of construction and planning, after a long cruise through the inner solar system and past Jupiter and out into the cold distances beyond, finally fired its main engine and slowed itself enough to be captured by Saturn's gravity and enter orbit. Cassini did not fly past Saturn. It stayed. That was the difference. That was the thing that made all the difference. It stayed, and it orbited, and it looked, year after year, with patient scientific instruments, from changing angles in different wavelengths of light, and gradually, over many years, the faint and secret things of the Saturn system came into view. Cassini saw the G-ring in a way no instrument had managed before. It saw the arc within the ring, the bright concentration of material along a stretch of roughly 60 degrees of the ring's full circle, a partial ring within a ring, about 1/6 of the way around the orbit, far more concentrated and reflective than the rest. It saw the arc the way you might, after your eyes have adjusted long enough to the dark of a room, begin to make out not just the vague shapes, but the specific features, the edge of a shelf, the frame of a picture. Details that were always there, but required a kind of sustained, patient attention to resolve. And within that arc, on the 15th of August 2008, the Cassini Imaging Science Team found it. They were not precisely looking for a moon. They were studying the arc, trying to understand its structure, its brightness, the way its material was distributed. And within the arc there was a point, a small, bright, resolved point of light, an object, something distinct from the surrounding dust and particles, something solid and present and there. A moonlet, embedded within the bright arc, orbiting within it, inseparable from it. Tiny, tiny beyond what the word usually carries in astronomy, where small often means something the size of a modest mountain range. This was tiny, even by the standards of tiny, a body a few hundred meters across, the size of a place people go to watch a game, floating in a ring of ancient ice. It was given the provisional designation S2008 S1, which is the procedural language of new discoveries in the Saturn system. S for Saturn, 2008 for the year of discovery, S for satellite, 1 for the first such body found in that year. A bureaucratic name, functional and forgettable. But the following year, in 2009, the International Astronomical Union, the body that governs the naming of things in the sky, that decides what celestial objects are called and makes those names official, gave it a proper name, drawn from the same reservoir of mythology that has named so many of the small, strange, peripheral things of the solar system. They called it Aegaeon. The name comes from Greek myth, from a figure also known as Briareus, one of the hecaton shares, a word that means, in rough translation, the 100-handed ones. These were enormous, terrifying figures in the oldest layers of Greek mythology, children of Uranus and Gaia, of sky and earth, born with 50 heads and 100 arms each. Giants so extreme in their nature that even the gods found them difficult to fully reckon with. Briareus, the one who became Aegaeon, appears in the Iliad, invoked as a name so mighty that even Zeus was calmed by it. There is something odd and funny and quietly touching about giving that name, the name of a 100-handed giant, a child of sky and earth, a being of mythological enormity, to something half a kilometer across, something smaller than most city neighborhoods. Something you could walk the circumference of in an afternoon if you could somehow keep yourself from bouncing off into space. But perhaps that is the point. Perhaps the name is not a mismatch, but an acknowledgement of something deeper, that in the economy of the universe, something tiny can still be extraordinary. That scale is not the same as significance. That a half-kilometer lump of ancient ice, drifting in its arc, quietly feeding a ring with its own body, deserves a name from the oldest stories, because what it is doing is, in its patient and unhurried way, as elemental as anything the myths describe. The sibling arc moons, the little bodies orbiting in their own faint rings elsewhere in the same outer region of the Saturn system, are named for related mythological figures, the Alkyonides, figures associated with Aegaeon in these oldest stories. They are a family in the myth, and they are a family in the science, which is a kind of symmetry that pleases something in the mind that might not be entirely rational, but feels, in the dark of a quiet night, like the right kind of thing. So there is Aegaeon, named, located, catalogued as Saturn LIII, the 53rd moon of Saturn in the official sequence. Half a kilometer of ancient, porous ice, drifting near the inner edge of the faint G-ring, embedded in the bright arc that marks the most concentrated part of that ring, orbiting Saturn in just under 20 hours. Discovered not because anyone went looking for it specifically, but because Cassini stayed long enough and looked carefully enough at the right piece of the sky at the right moment. A body so small that without Cassini's years of patient attention it would have remained invisible, present but unknown, doing its quiet work in the dark with no one watching. And that work, the work it has been doing all along, long before anyone named it, long before anyone knew it was there, is the thing we have been coming toward. The thing that makes Aegaeon more than a statistics entry in a catalogue of small moons. The work of becoming a ring. The slow, ongoing process of dissolution that makes Aegaeon and its arc not two separate things, but one thing in two states. One of them still coherent, and one of them already scattered. This is where the mechanism begins. Picture the space Aegaeon moves through. It is not empty space, not in the way that the word empty suggests a total absence of everything. Space is never entirely empty, even in the most vacant seeming regions between the planets. There are particles out there, fast-moving specks of dust and debris left over from the formation of the solar system, shed by comets, released by other bodies, drifting on long, slow orbits through the inner and outer solar system. Some of them are vanishingly small, smaller than the particles of dust that you might see floating in a shaft of sunlight through a window, micrometeoroids, the technical name for them. A name that simply means very small meteoroids, particles so tiny that they would be invisible to the naked eye and barely register to the touch, if somehow you could touch them. But they move fast. They move at the velocities of things in orbit, kilometers per second, and at those velocities, even the most negligible speck carries enough energy to make an impact, to chip, to gouge, to knock loose whatever it strikes. Aegaeon moves through a constant rain of these particles, not a torrential rain, not a pounding, a slow, continuous, ancient drizzle of microscopic impacts, each one individually too small to notice, each one removing some infinitesimal amount of material from wherever it strikes. Whether that is the surface of a larger body with enough gravity to hold most of the debris in place, or the surface of something like Aegaeon, where gravity is so near to nothing that the rules are completely different. When a micrometeoroid strikes the surface of a body with real gravity, the Moon, for instance, or a large asteroid, the material it displaces does not all escape. Most of it falls back. The crater forms, the ejecta flies out, and most of that ejecta comes down again. Because there is enough gravitational pull to recapture it. Over billions of years, this process churns the upper layer of the surface into a fine powder called regolith, the thin grey soil that covers the lunar surface, the blanket of pulverized rock that the Apollo astronauts left footprints in. The impacts do work, they change the surface, but the body retains most of its mass. It is scarred, but it is not diminished in any meaningful way. On Aegaeon, something else happens entirely. When a micrometeoroid strikes, and they are striking all the time continuously in the slow drizzle that Aegaeon has been moving through for all of its existence, the material that gets knocked free does not have much of a gravitational pull to overcome. The escape velocity is a few centimeters per second. The fine particles of ice and dust that an impact liberates from the surface are moving far faster than that already, simply from the energy of the collision. They do not arc upward and fall back. They escape. They leave the surface of Aegaeon with more speed than Aegaeon's gravity can overcome, and they drift away into the surrounding space, into the ring arc, becoming part of the diffuse material that makes up the arc's brightness, the arc's presence, the arc's light. Every impact is a small loss, a tiny reduction in the amount of Aegaeon that is still Aegaeon. A few grains here, a few grains there, nothing individually visible, nothing individually countable, but continuous. Ongoing, always happening. And the material that leaves does not go far, it joins the arc, circling in the same orbital path. Spread and diluted by the dynamics of the ring, but still there, still in the neighborhood, still part of the same system. Aegaeon is not losing itself into empty space, it is losing itself into the arc around it. And the arc is, in part, in significant part, Aegaeon, that is the core of the mechanism, the heart of the process. The bright arc within the G-ring is not separate from the moon inside it. The moon is the source, the arc is the moon, spread out. And the moon is slowly, very slowly, on timescales that dwarf the entire recorded history of every civilization that has ever existed on Earth, becoming the arc entirely. A moon becoming a ring, a solid thing becoming a scattered thing. One state of matter resolving into another, not through violence or explosion, but through the patient, continuous arithmetic of small losses accumulated over an unimaginable span of time. And this physical fact, this actual mechanism of how a tiny world loses itself to the space around it, is the thing we have been building toward. This is what Aegaeon is. Not just a moon, not just a ring particle source, but a body in the act of transformation, a world at the edge of two states, more fully itself than it will ever be again, and less itself with every passing moment, which is also more beautiful with every passing moment, if you are willing to look at it that way. We will come, in time, to the rest of it, to the force that holds the arc in place, to the distant moon that keeps the scattered dust from dispersing further, to the family of similar small bodies elsewhere in the Saturn system doing the same quiet thing. All of that is ahead of us, and we will arrive at it unhurried. But for now, let Aegaeon be what it is. A loose, porous, roughly half-kilometer body of ancient ice, orbiting near the inner edge of the faint G-ring at about 167. 500 kilometers from the heart of Saturn, completing each circuit in just under 20 hours, found on the 15th of August 2008, by the patient eyes of the Cassini spacecraft after decades of barely there hints, a particle shadow in 1979, a faint smear of light in 1980 and 1981, then silence and inference until the years of dedicated orbital observation finally resolved a bright point within an arc. Within a ring. A body so small that its own gravity is almost not there, so that every tiny impact, every micrometeoroid that strikes its surface in the endless patient rain of deep space sends a little more of it away into the surrounding brightness, drifting, shedding, becoming, not in any hurry, not with any urgency. In the same slow, patient, geological manner that the whole Saturn system moves and changes, on timescales that make the word slow itself feel approximate and insufficient. Out there in the dark, in the cold, in the thin sunlight that reaches Saturn's orbit at a fraction of the intensity we know here, Aegaeon floats in its arc, and the arc is made of Aegaeon, and Aegaeon is slowly joining the arc. And none of it requires any watching to continue. It will go on whether we watch or not. It has been going on since long before anyone watched, and in that, if you let yourself feel it rather than only understand it, there is something very restful. So let us stay with that restfulness for a moment, and then let us go deeper into the mechanism itself. Because the mechanism is where the real wonder lives, and it is the kind of wonder that does not demand alertness. It only asks that you follow one idea, slowly, all the way to where it leads. The idea is this: Aegaeon is shedding itself into the arc it orbits inside. And the reason it can do that, the reason the dust does not simply fall back down, the way dust falls back to the floor when you disturb an old shelf, is gravity, or rather the near total absence of it. On Earth, if you drop a grain of sand, it falls. The planet is so massive, its gravitational pull so overwhelming, that the tiny grain has no choice. It returns. Everything returns, on Earth. We are surrounded by gravity so familiar and so complete that we rarely think of it as a specific quantified force. It is simply the background condition of being here. Things fall. Dust settles. Water runs downhill. The world pulls everything back to itself, and we live inside that pulling without noticing it the way fish do not notice water. Aegaeon is nothing like that. Aegaeon is roughly half a kilometer across, about 500 meters, a stadium end to end, a small city block, and its mass, its total accumulation of ancient icy material, pressed loosely together over billions of years, is so much smaller than Earth's, so many orders of magnitude smaller, that the gravitational field it generates at its own surface is almost not there at all. Not zero, technically, but so close to zero that the practical effect is essentially the same. The escape velocity at Aegaeon's surface, the speed you would need to reach in order to fly away from it and never return, is on the order of centimeters per second, perhaps a fraction of a meter per second. To put that in terms a body understands, you could throw a baseball and it would leave the moon forever. You could jump, not hard, not with any particular intention or effort, and you would drift upward and outward and never come back. Walk too quickly, and the ground would fail to hold you. Even a careful, deliberate step might generate enough upward momentum to send you slowly, gently tumbling into space, with nothing but the distant gravity of Saturn itself to eventually pull you into a new orbit. This is not a metaphor. This is the physics of being half a kilometer wide in a system where the dominant force belongs to a gas giant 167,500 kilometers away. And this is why Aegaeon dissolves when a micrometeoroid strikes, and they are always striking, in the slow, patient rain of interplanetary dust that fills every part of the solar system, tiny grains moving at high speed relative to whatever they hit, invisible individually, ceaseless collectively. When one of those grains strikes Aegaeon's surface, the collision releases energy. It chips material free. It knocks loose a spray of fine dust, smaller than the original grain in many cases, just the uppermost skin of the ice lifted and shattered and sent outward. On a large body, on the Moon or on Mars or on any world with real gravity, that spray would arc and fall back. The ejector, as planetary scientists call it, the material ejected by the impact, would follow a brief ballistic path and land somewhere nearby, redistributing itself across the surface. The body would remain whole. Impact craters are filled partly with their own ejector that never quite escaped. On Aegaeon, the ejector does not come back. The escape velocity is so low, the gravitational grip so thin, that even the slow, modest dust raised by a micrometeoroid impact can find its way free. Not all of it, some of the very finest material might be moving too slowly, even relative to Aegaeon's faint pull, and might drift back. But much of it, perhaps most of it, simply drifts. It rises from the surface, follows the slight upward momentum the impact gave it, and then continues into the space immediately surrounding Aegaeon, into the orbital neighborhood, and from there, spreading gradually along the path of the orbit itself, accumulating over time, mixing with whatever material was already there, catching what little sunlight reaches Saturn's distance, and scattering it in the soft, diffuse way that dust scatters light, not a sharp reflection, but a gentle glow. A brightness that is not quite the brightness of a solid thing. The G-ring arc. That glow, that faint curved band of light that the Cassini spacecraft imaged so patiently from its orbital vantage point, is not separate from Aegaeon. It is Aegaeon. Not all of it, the arc also contains smaller companions, an unseen population of chunks and rubble too small for Cassini to resolve individually, all sharing the same orbital neighborhood, all contributing their own shed material. But Aegaeon is the largest of these, the one body in the arc big enough to find with an instrument's eye and name, and its contribution to the arc's brightness is real and significant. The moon floats inside the ring it is making. The ring is built from the moon's own surface. They are, in a sense that feels almost philosophical, but is actually just physics, the same body in two different states. One still concentrated, one already dispersed, with the transition happening continuously, grain by grain, impact by impact, in the dark and the cold and the thin outer light of the solar system. There is a quality to that image that I want to hold still for a moment, because it is easy to let it pass too quickly. We tend to think of moons and rings as different kinds of things. A moon is a world, however small, a discrete object, a body with a shape and a name, something you could stand on in principle, even if you would have to stand very carefully, something that can be pointed to and said, "There it is." A ring is different. A ring is a collective, a statistical behavior, a billion separate particles moving in similar enough orbits that from a distance they appear as a unified structure. The particles in a ring are not touching each other. They are not stuck together. They are simply in the same neighborhood, and their shared neighborhood is very thin and very flat. And so from far enough away, the neighborhood looks like a surface, a sheet, a ring. The individual particles are anonymous. They have no names. They are just grains of ice, grains of dust, small irregular chunks of rock and frost, all going around together. Aegaeon collapses that distinction. Here is a body with a name, small enough to sit comfortably inside a city block, but real and individual enough to be pointed to. There, in that bright arc, that faint curved glow, there is Aegeon. And that faint curved glow is also Aegeon, distributed and dispersed and slowly joining itself to the collective. It is a moon becoming a ring by the most patient possible means. Not an explosion, not a collision violent enough to break it apart all at once, not any dramatic catastrophe. Just the endless quiet rain of micrometeoroids, just the near-total absence of gravity at its surface, just material leaving and not returning, day after orbital day, for timescales long enough to make individual years feel like an eye blink. The process is not fast. It is not happening on any timescale that a human life could register. Even an instrument as patient and precise as Cassini, watching for 13 years in Saturn orbit, would not have detected any measurable change in Aegaeon's size. The dissolution is real, and it is ongoing, and on astronomical timescales, the kind of timescales over which mountains rise and erode, over which oceans form and evaporate, over which whole geological eras unfold and close. It is significant, but measured in decades or centuries, it is invisible. Aegaeon simply is what it is, and the arc is what it is, and the slow exchange between them continues beneath any threshold of immediate observation, which is, in its way, a relief. Something does not have to be happening quickly to be real. Something does not have to be visible in a human lifetime to matter. The dissolution is gentle, and gentle things last. Now, even if you understand the mechanism of the dissolution, the micrometeoroids, the near-zero gravity, the escaping ejector, there is still something that might puzzle you, and it is the right kind of puzzle, the kind that leads somewhere. Because if Aegaeon is constantly shedding material into its orbit, if dust is continuously leaking away from its surface and spreading outward into space, you might expect that material to gradually smear itself all the way around Saturn. Rings, after all, are rings, circles. If you start releasing material into an orbit, and that orbit is a circle around a planet, over time the material should distribute itself all the way around, should fill in the gaps, should eventually become a complete thin ring encircling the whole planet. But it has not. The G-ring arc is not a complete ring. It is an arc. A partial circle, a curved segment that spans only a fraction of the way around Saturn, roughly 60 degrees of longitude, which is about 1/6 of the full circumference. Aegaeon floats inside that arc. The arc contains Aegaeon's shed material and the material from its smaller, unnamed companions. And after all the time this shedding has been happening, all that material is still there, still confined, still occupying that same 60-degree slice of the orbital path, not dispersed into a full ring. Something is holding it in place. Something is acting as a fence. That something is Mimas. Mimas is not a small moon. By the standards of Saturn's inner system, Mimas is a substantial body, roughly 396 kilometers across, which is small enough to feel intimate compared to Saturn itself, but enormous compared to Aegaeon. Almost 1,000 times larger in diameter and vastly, incomparably more massive. Mimas has enough mass to have pulled itself into a rough spherical shape, which is more than Aegaeon can say. And Mimas has a feature that has made it one of the most visually recognizable moons in the solar system, the Herschel crater. A single enormous impact basin, roughly 130 kilometers across, which covers so much of Mimas's face that the moon has an unmistakable resemblance to a certain spherical weapon from a science fiction film made in 1977. Astronomers call it, with a mixture of affection and mild exasperation, the Death Star moon. The nickname has stuck in a way that official designations rarely do, because the resemblance is genuinely striking, a smooth sphere with one enormous circular depression sitting near the equator, looking for all the world like a constructed thing rather than a natural one. That is Mimas, the Death Star moon, 396 kilometers across, orbiting Saturn at a distance of about 185,500 kilometers from the planet's center, taking roughly 22.6 hours to complete one full circuit. And Mimas is, among other things, the reason the G-ring arc exists where it does and stays where it stays. The mechanism involves a resonance, not a sound. The word sounds musical, and in fact there is something almost musical about the mathematics involved, but resonance here is a gravitational phenomenon, a specific relationship between orbital periods. Aegaeon orbits Saturn once every 0.81 Earth days, or roughly 19.4 hours. Mimas orbits Saturn once every roughly 22.6 hours. Those numbers are not random. They are related. Aegaeon completes 7 full orbits of Saturn in very nearly the same time that Mimas completes 6. 7 to 6. For every 6 times Mimas goes around the planet, Aegaeon has gone around 7 times, and when you work out the geometry of those two bodies moving at those two rates around the same central body, you find that there are specific points in their orbits where they pass each other, where Mimas is at a particular position and Aegaeon is at a particular position, and those close approach points are not random either, they tend to cluster. Mimas's gravitational pull, applied repeatedly at the same part of Aegaeon's orbit, nudges the moon in a way that is consistent rather than random. Rather than averaging out to nothing over time, the nudges reinforce each other. This is the 7.6 corrotation eccentricity resonance. It is the invisible fence. What the resonance does, essentially, is create a region of gravitational stability, a zone where the push and pull of Mimas's repeated, patterned gravitational tugs acts to confine rather than scatter. Material in that zone, whether it is Aegaeon itself or the dust Aegaeon has shed, experiences gravitational forces that tend to keep it within a particular arc of longitude. If a grain of dust drifts ahead of the arc toward the zone where the resonance exerts a backward tug, the resonance slows it and pulls it back. If a grain drifts behind, the resonance speeds it forward. The arc is, in this sense, a stable place, not because nothing can reach it, but because the gravitational forces conspire to keep material from easily leaving it. The arc endures, and Aegaeon, floating in the arc it feeds, is also held there by the same mechanism that holds the arc itself. Think of it this way. Imagine you are on a very long beach, and the tide comes in and out, and there is one particular stretch of sand where the water always deposits shells, not randomly along the whole beach, but there, in that one spot. Because the shape of the coastline and the pattern of the current conspire to funnel shells to that place and keep them there. The shells accumulate, the current holds them. Even as individual shells shift and settle, the collection stays where it is, because the forces governing their movement are not random but patterned, and the pattern favours that stretch of beach over any other. You could scoop up a handful of shells and toss them into the water and come back the next day, and some portion of them would be back on that same stretch, or still there, because the current kept returning them. The G-ring arc is something like that stretch of beach. The resonance with mimas is something like the current. And Aegaeon, embedded in the arc, is both a shell and the source of new shells, shedding material that the current collects and keeps nearby. The reach of this resonance is worth dwelling on. Mimas orbits at about 185,500 kilometers from Saturn's center. Aegaeon orbits at about 167,500 kilometers. The gap between them is roughly 18,000 kilometers. For context, the distance from New York to Los Angeles is about 4,500 kilometers. The distance from Mimas to Aegaeon is more than 4 times that, and it varies as both moons move through their orbits. Mimas has never touched Aegaeon. It has never come anywhere near it. And yet Mimas's gravity, felt across all that distance, felt in the specific repeating pattern of a 7:6 ratio, holds a half-kilometer speck in a gravitational fence it cannot see and has no way to register. The speck does not know it is corralled. The fence has no posts. It is made entirely of mathematics, of the recurring geometry of 2 bodies moving in curved paths around the same immense center, and it is real, and it works, and it has been working for longer than there has been anyone to describe it. There is something in that image, the distant, scarred, crater-faced moon, reaching across 18,000 kilometers of empty space to hold a speck of ancient ice in place, that I find genuinely quiet to think about. Not dramatic, not violent, just patient and precise and vast, the way the solar system is vast, full of relationships that operate across distances that have no intuitive human scale. Sustained by forces that do not require any active attention to continue. Mimas does not try to hold Aegaeon, it simply moves through its orbit, and the geometry of that movement is enough. Now, there is a question that the dossier holds open on purpose, and it is a good question, the kind that does not have a clean answer, the kind that you can sit with rather than needing to solve before you sleep. The question is this: which came first? Did the arc make Aegaeon, or did Aegaeon make the arc? The mechanism we have been describing runs in one direction. Aegaeon sheds material. That material feeds the arc. The arc is partly made of Aegaeon. Moon makes ring. But there is another possibility, and planetary science takes it seriously. It is possible that the arc came first, that some event long ago, some collision or disruption in the early history of the Saturn system, scattered a cloud of material into the orbital zone now occupied by the G-ring's arc, and that cloud of material, corralled by the resonance with Mimas, gradually accumulated and clumped and coalesced. Small particles stuck together. Larger lumps attracted smaller ones. Over time, from a diffuse cloud of scattered debris, a body grew, not large enough to become spherical, not massive enough to sweep the arc clean, but solid enough to persist as a distinct object. Aegaeon, accreted from the arc. The ring making the moon. Both processes are, as far as current understanding can establish, physically plausible. And both may be happening simultaneously. The arc may have produced Aegaeon in the past, and Aegaeon may be feeding the arc in the present. So that the relationship between moon and ring is not a simple one-way flow, but a conversation, a loop, a body contributing to and drawing from the same reservoir across different timescales. The moon grew from the ring, and now the ring grows from the moon, and neither is simply the cause of the other. Cassini did not fully resolve this question. The spacecraft spent years watching the G-ring arc, building a picture of its structure and brightness distribution, confirming Aegaeon's position within it, measuring the resonance's effects on the arc's confinement. But the initial formation event, whatever disruption or accumulation first gathered material into that arc long ago, happened before Cassini was there, and perhaps before any instrument was close enough to observe. The question of origin is, for now, genuinely open. Not because scientists have failed to look, but because the evidence that would settle it has likely been erased by time, smoothed over by billions of years of ongoing orbital evolution. What Cassini did confirm is that Aegaeon is almost certainly not alone in the arc. The resonance that holds Aegaeon in place holds other things in place too. Smaller things, things that Cassini's instruments could detect only as a diffuse brightness within the arc, not as distinct individual objects. The current best understanding is that Aegaeon is the largest member of a population, that the arc contains a whole swarm of smaller bodies, companions to Aegaeon that are too small to image individually, loosely corralled by the same gravitational fence, each contributing its own slow trickle of shed material to the collective glow. How many of them are there? Unknown. How large are the largest of them, the ones just below Cassini's resolution limit? Unknown. Whether any of them have their own distinct shapes, their own irregular surfaces, their own particular histories of impact and erosion and slow dissolution, unknown. They are there, probably, quiet, unnamed, too small to have been found by the only spacecraft that spent time in their neighborhood. They float in the same arc as Aegaeon, subject to the same micrometeoroid rain, losing their own material by the same near-zero gravity mechanism, contributing to the same faint brightness that Cassini read as the G-ring arc's glow. And now Cassini is gone, as we will come to, and the arc holds its secrets more quietly than before. But here is what does not change with the uncertainty. The mechanism is real. Aegaeon is real. The resonance with mimas is real. The near-zero escape velocity is real. The micrometeoroid rain is real. And the arc, that faint, partial 60-degree curve of diffuse light embedded in the G-ring between the F-ring and the E-ring, is real. And it contains within it both the largest named object in that arc and the scattered material that object has already given away. Whatever the precise history, whatever came first, and in what order, the present state of things is not in serious doubt. A body is there, and the region around it is brighter, because the body is losing itself into that region. And the same gravitational relationship that pins the body to its location also pins the brightness to its location, and all of it, the solid thing and the diffuse thing, is the same phenomenon, the same slow process, seen from two different distances. This is what I mean when I say Aegaeon collapses the distinction between moon and ring. Not metaphorically. Physically, the two categories, which seem so obviously different from a distance, blur and merge when you look closely at something this small. Moving in an environment where gravity is both absolute and almost absent. Absolute in the background, in the distant pull of Saturn and the distant pattern of Mimas, and almost absent at the surface of the tiny icy body itself. In that particular combination of forces, the boundary between a world and a ring becomes negotiable. Becomes, in fact, a process rather than a state. And that is the thing I want to leave with you here, at the center of this account, in the part of the evening where the day has finally stopped pulling at you and the dark is comfortable, that a boundary you took to be fixed can turn out to be a process. That what looks from a distance like a clear distinction, a thing is either a moon or a ring, a thing is either whole or dispersed, is, up close, a question of timescale and perspective. Aegaeon is both. It is a moon, named and catalogued Saturn the 53rd, with a number and a history and a place in the official record of the solar system's known bodies. And it is a ring, or the source of a ring, or the ring's largest remaining concentration, depending only on how long you watch and how closely you look. There is no point at which Aegaeon stops being a moon and starts being a ring. There is only the process continuing. The dust leaving, the arc catching it, the resonance holding both in place. And somewhere in the middle of all that, a body that is neither one thing nor the other, but is becoming, always becoming, slightly more dispersed, slightly more distributed, slightly more shared with the space around it. Not gone, not lost. Spread, there are more pieces of this to lay out, and we will lay them out in the order they belong. The companions in the arc, who share Aegaeon's nature and its situation, the sibling moons caught in their own resonances, the wider gallery of rings and moons across the Saturn system, where this same conversation between solid and scattered plays out in different registers. And the machine that found all of this, the spacecraft that spent 13 years in Saturn's neighborhood accumulating the evidence from which we know what we know, and what became of it in the end. All of that is still ahead. The night has time. You have time. For now, stay here a moment longer. In the arc, with the dust and the resonance and the small, unnamed companions floating in the same corralled brightness as Aegaeon, none of them knowing they are held, none of them needing to know. The fence of mathematics holds them regardless. Mimas turns slowly through its orbit, scarred and spherical, its enormous crater facing outward into the dark, its gravitational pattern reaching inward across 0 kilometers, to keep a speck of ancient ice in place, to keep the arc of shed dust from smearing around the ring and disappearing into the general glow. The fence holds, the resonance persists, and Aegaeon floats in the middle of it all, losing itself grain by grain into the brightness it has made. Grain by grain. Not rushing, not resisting, just continuing, the way all the slow, real things continue. Aegaeon is not alone in this. That is the thing the arc makes easy to forget. Floating inside one small bright curve of the G-ring, it can seem like a solitary phenomenon, a single oddity, a moon that happens to be dissolving in an unusual way in an unusual place. But the Saturn system, as Cassini revealed it across those 13 years of accumulated observation, is not built around oddities. It is built around patterns. And the pattern that produced Aegaeon, a tiny body, a resonance with mimas, a ring arc fed by its own slow erosion, did not produce only one such body. It produced a family. They all have names now. They were all found by Cassini, found by the same patient method of looking carefully at the faint outer rings and noticing that one of the points of light within them was a little too consistent, a little too stable, a little too bright to be explained by the arc alone. Each name comes from the same mythological neighborhood as Aegaeon, figures from the deep registers of Greek mythology. Smaller figures, figures who orbit the edges of the great stories rather than standing at their centers. The naming itself is a kind of pattern. They belong together in the catalogue the way they belong together in the sky, small, faint, quietly present, leashed to the same distant shepherd. The nearest sibling in terms of the category it belongs to is Anthe. Anthe is about 1 kilometer across, roughly twice the size of Aegaeon, though still, by any ordinary measure, impossibly small for a named moon of a giant planet. A kilometer, the length of perhaps 10 or 12 city blocks laid end to end. If Aegaeon is a large sports stadium drifting through space, Anthe is a small neighborhood. And Anthe, like Aegaeon, sits embedded within its own bright arc, the Anthe arc, a partial ring. A confined curve of dust and small debris that does not complete the circle but holds itself in a concentrated band, not dispersing, not spreading into the general faint glow of the G-ring region. The resonance that holds the Anthe arc is also a resonance with Mimas. Mimas, that distant scarred world, that moon whose enormous Herschel crater gives it its famous resemblance to a certain well-known fictional space station. Mimas is the shepherd here too. Its gravitational pattern reaching outward and inward across tens of thousands of kilometers to maintain the invisible fence that keeps Anthe and its arc material from dissolving into the wider ring. The same mechanism applied to a slightly larger body, producing the same result. A small moon inside its own arc of shed dust. Held in place by a resonance with a moon it will never come anywhere near. There is something remarkable about this, if you let yourself rest in it for a moment. Mimas is not a large moon, as moons go. It is about 396 kilometers across, not tiny by any means, but not one of the great moons of Saturn, not a Titan, or a Rhea, or a Dion. And yet, Mimas reaches its gravitational influence, organized into the precise mathematical ratios of orbital resonance, extends across enormous distances to hold bodies it could never interact with in any direct or physical sense. Mimas and Aegaeon will never collide. They will never pass close enough to exert any obvious gravitational tug in the way that, say, two nearby bodies might slingshot each other into new orbits. The interaction is almost entirely about rhythm, about the way two orbits, cycling at different speeds, can fall into a ratio that causes one to reinforce the other over and over, in the same way that a child on a swing can be kept aloft by a push given at exactly the right moment in every cycle. 7 orbits of Aegaeon for every 6 of Mimas. That is the ratio, 7 to 6. A 7.6 corrotation eccentricity resonance, to use the precise term. And the same principle, wearing a slightly different numerical face, holds Anthe in its arc. Different number, same principle. The resonance is the shepherd. Mimas is only the body whose orbital rhythm the resonance is measured against. The third sibling is Methone, and Methone is extraordinary enough to deserve a moment of careful attention even in the context of a night like this one, when the mind is growing softer and the distances are growing larger and everything is beginning to blur a little at the edges in the way that late nights do. Methone is about 3 kilometers across, 6 times larger than Aegaeon, still small enough to hold in your mind as a single object, still small enough that its surface gravity is close to nothing, still small enough that micrometeoroid impacts kick dust off it the way they kick dust off Aegaeon, feeding the arc it floats inside. The methone arc. Another partial ring, another curve of concentrated brightness along the inner edge of the G-ring region, another arc held in place by a resonance with mimas. But methone is not remarkable primarily for its size or its arc or its resonance. Methone is remarkable for its shape. When Cassini imaged it, and it imaged it well enough to reveal actual shape. Unlike Aegaeon, which remained a point of light, what the Cassini cameras showed was an egg. A smooth, nearly featureless, slightly elongated egg, like a river stone worn smooth by years of water, except that there is no water in the outer reaches of the Saturn system, only space and micrometeoroids and the slow patient grinding of time. The smoothness of methone is itself a clue to the same process that is dissolving Aegaeon. On a world with essentially no gravity, impacts do not create craters the way they do on the Moon or on Mars or on bodies large enough to hold the shock of impact in place. Instead, the impact ejector simply escapes. The loose, shattered material does not pile up into a rubble field around the impact site. It drifts away. And what drifts away from one region can settle gently back across the whole surface, drawn by the tiny but real gravitational pull of the body itself, and it settles evenly, covering the old relief, filling the old craters, rounding everything down to a smooth, continuous curve. Methone has polished itself with its own escaped and recaptured dust. It has worn itself featureless by the same process that sends some of its mass outward into the arc and never returns it. An egg in space, smooth as a worry stone, about 3 kilometers from end to end. And methone floats inside the methone arc, held there by a resonance with mimas, feeding its arc the way Aegaeon feeds the G-ring bright arc, losing itself slowly into the faint brightness it has made. The pattern by now is visible, mimas as the distant shepherd, the resonance as the invisible fence. The tiny body inside the arc, shedding itself into the arc through micrometeoroid erosion, the moon and the ring being the same body in 2 different states. Aegaeon, Anthe, methone, 3 small worlds, 3 separate arcs, 3 separate resonances with the same distant moon, all of them quietly dissolving. The Saturn system is doing this in multiple places at once, and it has been doing it long enough that these arcs exist to be observed, which means the erosion has been happening for a very long time. Which means these moons were once, presumably, larger than they are now, and are now smaller than they will eventually be. And then there is Pallene. Pallene is about 5 kilometers across, larger still within this family, though still tiny by any planetary standard, and Pallene has done something that Aegaeon and Anthe and Methone have not yet fully done. Pallene has made not an arc, but a ring, a complete ring. The Pallene ring is not a partial curve, not a 60-degree concentration of bright material along a fraction of the orbit. It is a full circle, faint, diffuse, barely detectable even by Cassini's instruments, but complete. Pallene has shed enough of itself over enough time that the material has spread all the way around its orbit, and the orbit is now a ring. This is the direction Aegaeon is going. Not quickly, not in any timescale that maps onto a human life, or a human civilization, or even many human civilizations stacked end to end. But in the direction of the geological and astronomical, in the timescales where Saturn's rings were born, and where the moons that circle it have been circling for billions of years, in that register, Pallene is the future and Aegaeon is the present. Pallene got there first, or perhaps was always larger to begin with, or perhaps its resonance with Mimas is slightly different in character, allowing the shed material to disperse more evenly. The details are not all resolved. But the picture is clear. This family of small moons is on a continuum that runs from arc to ring, from concentrated partial brightness to complete diffuse circle, and the driving force is the same throughout: micrometeoroid erosion on a body too small to keep what it loses. The fence made by Mimas does not hold the material forever. It holds the denser concentration in place, the bright arc, but some fraction always escapes, always drifts outward. Always begins the slow diffusion that eventually, over long enough time, completes the circle. Pallene is the reminder that the fence is not a wall, but a tendency. It corrals, not perfectly, and what escapes the corral over time makes the ring. Aegaeon will do this too. The arc will spread, the ring will complete. The moon, whatever fraction of it remains by then, will float inside a complete faint ring of its own former body, no longer the source of a concentrated arc, but the seed of something continuous and encircling and larger than itself. It is a strange thing to consider if you let yourself consider it. A world becoming its own legacy, the substance of a body becoming the structure that outlasts it. But the Saturn system has never confined this tendency to the outer faint rings. It runs through the whole system, in different forms, at different scales, in different registers. In the bright main rings, the brilliant flat disk that makes Saturn instantly recognizable, even in the smallest backyard telescope. Those three broad bands of ice and rock that are almost certainly the remnants of a shattered moon or a captured body that strayed too close and was torn apart by Saturn's gravity long ago. Even in those rings, the conversation between solid and scattered continues, and the agents of that conversation are moons. Pan orbits inside the Encke Gap, a 325-kilometer wide gap in the A ring, the outermost of the main rings. Pan is about 28 kilometers across, and it keeps the Encke Gap open by sweeping up material that would otherwise drift inward and fill the gap. But Pan does more than sweep. As it moves through the ring, its gravity pulls on the ring material on either side of the gap, and the ring material responds by rippling, by rising up into waves along the gap's edges, waves that Cassini photographed in remarkable detail, long, luminous undulations, like the wake of a boat on a very still lake, except that the boat is a moonlet and the lake is a river of ice 100 meters deep and tens of thousands of kilometers wide. Pan writes in the ring with its gravity. The ring carries the inscription. Daphnis does the same thing, 42 kilometers wide, in the Keeler Gap, which is narrower, only about 42 kilometers across, and whose edges are correspondingly more tightly shaped by Daphnis's passage. The waves Daphnis raises in the Keeler Gap were one of Cassini's more striking images, clean, precise, repeating undulations in the ring edge, each one a record of Daphnis passing. A moon writing its presence in ice, over and over, the same sentence repeated endlessly in the ring. This is not dissolution. Pan and Daphnis are not losing themselves into the rings they shepherd. They are shaping them, inscribing them, maintaining the gaps that define the ring's structure. But the relationship is the same in its essence, a solid body and a ring of scattered material in a continuous, active exchange. The moon acts on the ring responds. The ring acts on the moon through the accumulated gravitational nudges of all the material it moves through. The moon responds. It is a conversation that has been going on for as long as those moons have been in those gaps, which is to say, a very long time. And then there is Enceladus. If Aegaeon is the quiet example of this tendency, a moon so small and still that its dissolution is almost meditative, almost a metaphor for the kind of letting go that a long night calls for, then Enceladus is the loud example, the dramatic one, the one that makes the news. Enceladus is not dissolving quietly. Enceladus is erupting. Enceladus is a moon about 504 kilometers across, one of the medium-sized moons of Saturn, and it is one of the most geologically active bodies in the solar system. Its south pole is covered in long parallel fractures. They are called tiger stripes, because that is exactly what they look like from above and from those fractures. Enormous jets of water vapor and ice crystals and organic molecules erupt continuously into space, shooting hundreds of kilometers above the surface, spreading outward into the orbit of Enceladus, and forming the vast, diffuse E-ring, the enormous and faint ring that lies far beyond the G-ring, extending outward for hundreds of thousands of kilometers in either direction from Enceladus's orbit. The E-ring is made of Enceladus. The ice crystals that compose it came from under the south polar surface of that active, warm, geologically extraordinary moon. They came from the liquid water ocean that Cassini confirmed exists beneath the ice, a saltwater sea in the dark interior of a moon barely 500 kilometers wide. A sea that has almost certainly been liquid for a very long time, and that contains, Cassini found, the chemical ingredients that on Earth are associated with the kind of hydrothermal environments where life begins. But the E-ring itself is the point here, for this night, for this slow comparison. The E-ring is a moon becoming a ring, exactly as the G-ring bright arc is a moon becoming a ring. The process is entirely different: eruption versus erosion, geysers versus micrometeoroids, an active and dramatic spray of material from an interior ocean versus a quiet and passive chipping of surface ice by the interplanetary dust that drifts through the whole solar system. But the result is the same. A moon is feeding a ring. The ring is made of the moon's own substance. The boundary between moon and ring is not a boundary but a gradient, a continuum, a long, slow transformation of one kind of thing into another. Aegaeon by erosion, Enceladus by eruption. Both of them are doing what the Saturn system seems, in some deep sense, to do, taking solid bodies and scattering their substance into the wider structures that surround them. The rings of Saturn are not a permanent backdrop against which the moons orbit. The rings and the moons are in conversation. They trade material, they shape each other, they blur into each other at the edges, in the faint outer rings, in the G-ring, in the E-ring, in the Pallene ring, in the small bright arcs where Aegaeon and Anthe and Methone float, losing themselves slowly into the light. And we know all of this because of a machine that was built by human hands in the 1990s, launched from Earth on October 15, 1997, and spent 7 years crossing the solar system before it reached Saturn and began the long, patient work of looking. Cassini entered orbit around Saturn on July 1, 2004. This is not a small fact. A spacecraft that left Earth in 1997, launched before most of the people listening to this tonight had smartphones, before many of them had access to the internet in any daily sense, built with technology that would seem modest by current standards. That spacecraft crossed the outer solar system and slowed itself into orbit around a planet 1 billion miles away without anyone being able to touch it or adjust it directly, guided entirely by the physics of orbital mechanics and the precise timing of its own rocket burns, and it worked. It entered orbit, and then it stayed. 13 years. Cassini spent 13 years in the Saturn system, sending back data continuously, imaging the rings and the moons and the storms in Saturn's atmosphere, discovering Aegaeon, finding the arc moons, confirming the ocean under Enceladus's ice, revealing the waves in the Keeler Gap, watching the slow processes that define how a ring system lives and changes. 13 years of accumulated observation compressed into the libraries of data that scientists have spent years and will spend more years working through, extracting from it the picture of the Saturn system that we now hold. Aegaeon was discovered by the Cassini Imaging Science Team on August 15, 2008, 4 years into that 13-year residence. Not by aiming a camera directly at the spot where a moon was expected to be, because no one expected a moon to be there. By studying the G-ring bright arc, by looking at the arc closely enough and patiently enough that the faint, consistent brightness of a tiny embedded body became distinguishable from the background glow of the arc itself, a point of light that was always in the same relative position within the arc, always bright in the same way, always behaving like something solid rather than something scattered. S2008 S1. That was its designation first. A string of letters and numbers, a provisional identity, a placeholder. The International Astronomical Union formalized the name Aegaeon in 2009, drawing it from the same mythological register as the other small arc moons, the Hecaton chairs, the 100-handed ones, the giants who were children of Uranus and Gaia, and who were so extraordinary and so strange that even the gods found them difficult to contemplate. Aegaeon, also called Briareus, a name from a tradition that knew how to give weight to strangeness, how to hold the uncanny inside a word and carry it forward across centuries. A name for a half-kilometer body drifting in a ring arc 1 billion miles from the sun. A name that will persist in the catalogue long after the arc has changed, long after the moon has continued its slow surrender into the ring. Cassini did not end the way most things end. It did not fail gradually, its instruments dimming one by one, its signal growing weaker until it was finally too faint to detect. That kind of ending was not available, because Cassini carried fuel, and when the fuel ran out, it would become uncontrollable, and an uncontrolled spacecraft in the Saturn system is a contamination risk. It could drift into contact with one of Saturn's moons, one of those moons where the conditions might support life, and it could carry with it the residual microbes from Earth that no sterilization process can entirely eliminate. The scientists who built Cassini and spent their careers on its mission could not allow that. So the mission had an ending built into it from the beginning, a deliberate ending, a chosen one. They called it the grand finale. In the final months of the mission, Cassini was directed into a series of orbits that brought it closer and closer to Saturn, passing through the gap between the innermost ring and the planet's upper atmosphere, a region of space that had never been visited. A region too close to the rings for any spacecraft to pass through safely during the working mission, saved for the end precisely because the risk was acceptable when the mission was ending anyway. Those final orbits collected data from regions Cassini had never been able to reach. The gravity field very close to Saturn. The magnetic field the composition of the ring material falling into the atmosphere. Science from the last kilometers, from the place where the rings end and the planet begins. And then, on September 15th, 2017, Cassini entered Saturn's atmosphere. It did not glide in peacefully. At those speeds, in that atmosphere, the spacecraft broke apart and burned, its components vaporizing one by one as it descended, its signal growing erratic, and then at last, silent, the machine that had found Aegaeon dissolved into Saturn. The observer became part of the thing it had observed. The spacecraft that had spent 13 years watching the slow conversion of moon into ring accomplished its own slow conversion, not into a ring, but into the upper atmosphere of the planet that had defined its entire working life. There is something in this that the mind wants to hold for a moment. Not because it is dramatic, though it is. Not because it is sad, though it contains sadness. But because it rhymes so precisely with the thing Cassini had been watching, the thing it had been documenting, the slow surrender of a solid body into a larger structure that will persist after the solid body is gone. Aegaeon, losing itself grain by grain into the arc. Cassini, losing itself layer by layer into Saturn. The moon dissolving into the ring. The spacecraft dissolving into the planet. What Cassini left behind is the data, the years and years of careful observation, the precise measurements, the images, the spectra, the mapped surfaces of moons that no other instrument had ever resolved. All of that persists. It is stored in databases and analyzed in papers and carried in the minds of the scientists who worked on it and who teach what they found to the students who will carry it further. The dissolution of the machine did not dissolve the knowledge. The scattering of the spacecraft did not scatter the understanding. What it had gathered, it had already given away, already sent back across the billion miles to be received and recorded and kept. A thing can break apart and still leave something. A thing can dissolve into something larger than itself and still, in the dissolving, have done exactly what it was for. That is what Aegaeon is doing. That is what Cassini did. That is perhaps what a long and tiring day does to a person, if the person allows it. If, instead of holding the accumulated weight of it tight and carrying it forward into the night, they allow it to soften, to spread, to become part of the wider dark around them, instead of a dense, solid thing pressing behind the eyes. Small and scattered is not lost, it is distributed. It is everywhere the arc is, instead of only in the center of the arc. It is the ring, instead of only the moon inside the ring. The Saturn system has been doing this for a very long time. The rings themselves, those brilliant, flat, almost impossibly thin bands of ice and rock that have made Saturn the most recognizable planet in any image of the solar system, those rings were not always there, or at least not in their current form. They formed at some point from something that was solid, something that was broken apart or torn apart, or gradually surrendered its substance into the orbit that had been its path. The material was always there in some configuration. It reorganized itself into the form we see, into the form Cassini photographed, into the form that billions of years of physics and gravity and micrometeoroids and orbital resonance sculpted. Aegaeon is a current example of a process that has been shaping this planet's appearance for longer than the Earth has existed in its current form. The tiny moon in the G-ring arc is not an outlier. It is a living instance of the general tendency of this system. In this region of the solar system, far from the warmth that organizes things differently. Out here, in the cold, the tendency is to scatter, to spread, to take the solid and make it wide, not all at once. Never all at once. Always slowly, on the timescales where 1 billion years is a meaningful unit of measurement, where the grinding of micrometeoroids on a half-kilometer moon is a significant geological process, where the 7-6 orbital resonance between a tiny body and a distant larger moon is an architectural element of the ring system rather than a curiosity. Everything on this scale is slow. Everything is patient. The dust is patient. The resonance is patient. The arc is patient, concentrated in its 60 degrees of longitude, not in a hurry to complete the circle. Though in time it will, because the tendency is always in that direction. Because Pallene has already shown the direction, and Aegaeon is following it in its own time. If you are still awake enough to follow this, then you have followed it to the edge where the facts end and the feeling begins. The feeling is this: a thing does not have to remain solid and bounded and whole in order to matter. A thing can contribute its substance to something larger, and in doing so, become something larger. The moon does not choose to become the ring. It does not resist becoming the ring. It simply continues to be what it is, a small, icy body in a resonance-corralled arc, and in continuing to be what it is, the ring grows. Aegaeon is Saturn LIII, the smallest named moon of the largest ring system in the solar system, 1/2 kilometer across, roughly, believed to be. Icy, porous, loose, its gravity barely enough to hold the word gravity in the same sentence without qualification. Orbiting at about 167,500 kilometers from Saturn's center, completing its circuit of the whole planet in about 19.4 hours, once every 81 Earth days, embedded in the bright arc along the inner edge of the G-ring, held there by the 7.6 resonance with Mimas, losing itself continuously to the arc, feeding the arc, being the arc. It has been doing this since before anyone was here to see it. It will continue doing it long after the instruments we might send to watch it have fallen silent. It does not require an audience. It does not require the name the International Astronomical Union gave it in 2009. It does not require the record in the catalogue Saturn LIII or the provisional designation S2008 S1, or the data in the Cassini archive, or this narration, or anyone listening to this narration in the dark. It is sufficient to itself. It continues. And somewhere outside whatever window is nearest to where you are listening tonight, the sky holds Saturn, though you probably cannot see it from where you are. Though you would need a clear night and patience, and a particular direction to look, and even then it would be only a point of light, only a star that does not quite twinkle the way stars do, only a suggestion of the rings that no naked eye can resolve. But it is there, Saturn is there, the rings are there, the G-ring is there, faint and dusty, far beyond the brilliant main rings, spread across its wide band between the F-ring and the E-ring. The bright arc is there, concentrated along its 60 degrees of longitude, composed of ice and dust and the shed substance of a tiny world. And Aegaeon is there, inside the arc, at the centre of it all, doing the only thing it has ever done, the only thing its nature allows it to do, which is to be small and to give itself to the space around it, one grain at a time, in the patient way that the Saturn system has always done its slow and beautiful work. The arc is quiet, the resonance holds, the dust drifts. If there are others awake, in other time zones, in other countries, in other nights that are just beginning where yours is ending, and there always are, they are listening to the same distances, breathing in the same direction of thought. Their minds also loosening their grip On the day the way a hand loosens around something it has been holding too tightly for too long. You are not alone in this. You are part of the arc, in a sense. All the people who have ever needed a night like this, a voice like this, a distance like this, to finally let the day go, they are distributed through the dark the way Aegeon's dust is distributed through the G-ring arc. Not lost. Present, spread into something wider than any one of them alone. If you feel moved to share where you are listening from tonight, the comments are there, and I read them. I would genuinely like to know. And there are more slow stories here, of the same careful and unhurried kind, waiting for whenever you want them. Stories from the dark corners of the solar system, from the edges of what instruments can see and physics can explain. From the places where a solid thing becomes a scattered thing, and the scattered thing is revealed to be, in its own way, more enduring than the solid thing ever was. But you do not need to find those now. You have come far enough tonight. Aegaeon has carried you far enough. The resonance has held long enough. The arc is complete for tonight's purposes, which is to say it is not complete. It is still 60 degrees of longitude out of a possible 360, still holding its concentrated brightness, still feeding itself from the small moon at its center, but it is complete enough. It has done what it needed to do. You have done what you needed to do. The day is done. The dust is drifting. Mimas turns slowly through its orbit, its great crater facing the dark. Its gravitational rhythm reaching across 18,000 kilometers to keep the small bright arc in place. Aegaeon floats. The arc glows faintly in the frequency of light that Cassini's instruments were sensitive to, that human eyes would need a spacecraft to see, that persists regardless of who is watching. Let the dark be comfortable and still. Let the distances do what distances do. They make the small things smaller and the long things longer, and the present moment very quiet, very close, very sufficient. You have been here for the dissolution of a moon into a ring. That is not nothing. That is a rare thing to have attended, even in the imagination, even at 1 billion miles of remove. Even through the filter of a late night and a tired mind, and the strange mercy of a voice in the dark. Put down whatever remains of the day. Let it drift. Let it join the arc of everything else that has already let go tonight, the unfinished thoughts, the half-held worries, the things that felt urgent this morning and feel distant now. As distant as the G-ring, as faint as the arc. As patient as the resonance that will still be there tomorrow. Good night from up here in orbit. I'll keep watch while you drift.